Okay, so a logarithmic function, right, that's got to have a y equals, right, which means you can't solve it explicitly, but you could graph a whole bunch of points, and they ought to have a characteristic shape. So this is that f of x equals log base b of x. Find the inverse. What are the steps to finding an inverse? Oh. Change the f of x to a y. Switch the x and the y. And then solve for y. Well, we don't have any way to divide by the letters log or, we don't know. But convert that to an exponential. What would you get if you converted it to an exponential? b to the x equals y. Y equals b to the x. So by converting it to an exponential, we did solve for y. Right? So what does that tell us? It tells you that exponentials and logarithms are inverses of each other. Okay? Remember, when we knew that two functions were inverses, when we took their composition, then everything canceled out and all you got was x, right? Kind of like what we just got on the property side, right? When you take the log base a of a to the x, you just get the x. So that's taking the composition of a logarithm and an exponential. What's that? Yes. Right, and it doesn't matter the order. Remember, when two functions are inverses, it doesn't matter if you do f of g or g of f. Everything cancels and you're just left with the x. Okay, what do we know about the graphs of inverses? See any? What'd you say? They're symmetric with respect to y equals x, right? They're a flip across the line y equals x. With respect to WRT, math speak.